Hello, my name is Rafael, Papa Uniform 1, Oscar Whiskey Lima, and today I'm going to show you the ATU 100. Well, I'm not going to show you the tuner, but the two modifications I made to mine to improve its performance. So, in one previous episode of Ham Nuggets, uh, Jim and Tio pointed out that I have changed some components in my ATU 100. Actually, they showed these exactly same pictures, and these two components here, pointed with arrows, are two diodes that compose the SWR bridge. How this thing works is really important to understand. Uh, Although many people say that the microcontroller is the brains of the ATU 100, it is actually the SWR bridge that governs everything. So if this thing reads the wrong values of the forward and the reverse power, the microcontroller will choose the wrong values of the capacitors and inductors. So pretty much, I consider the brains of this ATU the SWR bridge. And that's the main weakness on the Chinese build. So what I have here is the schematic of the SWR bridge from the N7DDC GitHub transposed to LT Spice. I'm gonna run some simulations. Actually, I'm not gonna run some simulations. I'm gonna show you because the simulations take a few minutes to run. It's kind of boring. So, but let me explain how this thing works. You have two transformers here. The first one measures the current on the transmission line, and the second one measures the voltage on this point. So these two transformers make a power measurement by doing the multiplication in an analog way. And what you have on this first resistor here, the 50 ohm resistor here, is uh, a sample of the forward power, but on the source frequency. So if you have a say 3 megahertz power source here, this power sample here is gonna have 3 megahertz. And the same way on the reflected power, if you have 3 megahertz here, you have 3 megahertz here. So this is kind of hard for the microcontroller to measure. So basically, what we do is we add this diode detector here. This diode and this capacitor here, or the other diode and the other capacitor, D1 and C17 and D2 and C16. And these two works as an AM detector. It's a peak detector. The remaining components you have on each side are for making the microcontroller happy with the voltage around 2 volts here, because you can have a large amount of voltage here. So pretty much on the left side you have the forward voltage, and on the right side you have the reverse. Actually, I said voltage, but it's actually something that's proportional to the power and reverse power on the other side. And if you want to know more about this SWR bridge, there is a site I'm gonna link on the description from K6JCA. It's a mine a mother load of information on SWR meters, so it's really good. And one thing to point out is that these diodes are very important on the SWR bridge. The N1N5711 has a very low forward voltage and an extremely low 1 picofarad capacitance on the junction. And this makes this thing behave almost like a perfect diode. And this is the weakness on the Chinese buildings of the N7DDC. Sometimes they choose the wrong diode, and I'm going to show you what happened to mine. So what I did here is on the right side you have the right circuit, see, and you have the 1N5711. On the left side, I added some 60 PF junction capacitors. That's because my own ATU had a diode that had almost 100 picofarads of junction capacitance. So I'm being generous here. it can be worse. And this simulation here shows what happens with a 50 ohm load and 3 megahertz frequencies is somewhere close to the 80 meter band. And as you can see, both on the right side and on the left side, you have the reverse, this blue line here, the reverse voltage corresponding to the reverse power, almost zero. And on the forward voltage, you have some around 2.1 volts. And we call it 100 watts. That's what I configure. But you see, so what am I complaining about? Those two circuits work the same. But look what happens on the 10 meter band. I changed the voltage source to 30 megahertz on both sides. And while with the correct diode, you have 0 volts on the reverse power and 2.1 on the forward. Now I'm measuring like half a volt on the reverse power and a little smaller than 2 volts, maybe 1.95 volts on the forward power. So this is a perfect match. And it seemed to me that it has like 2 to 1 SWR. So if the microcontroller sees that, he's going to try to match. He's going to try to match a perfect load with the wrong values. And you have a terrible, terrible ATU. For comparison, I made the same thing with a really high SWR load. It's a 450 ohm, which is 9 to 1 SWR. And again, on 80 meters or 3 megahertz, you don't have too many difference. You have maybe microvolts of difference. So the thing is gonna work perfectly on the lower bands. But once I get to the 10 meter, oh, the simulation is upside down. Sorry for that. Again, you have a much. Actually, this is even worse. No, it's you have the SWR a little higher than it should be, and the measure power also appears higher. So it's a mess. It's not the right measurement, and the microcontroller is gonna do the wrong thing when he sees that. So what was the diode I received? It was a BAT66, which is a high power Schottky diode instead of a small signal Schottky diode. That's the difference. And you may be asking right now, so what diodes can I use and what should I not use? I'm going to show you what can you use. You have two options on through-hole and a bunch of options on SMT. The through-hole, the standard is going to be 1N5711. This diode is great for RF. The other one that's really nice is the BAT41. On SMT version, you have the 1N711. It's the W suffix that shows it's SMT. And it's pretty much the same diode. But you have the BAT62, which is for microwave, and it's even better. The other diodes I put here, the BAT41Z, the 46Z, which I ended up using, and the BAT54, are really good up to 30 or 40 megahertz. They have like 4 picofarads of junction capacitance, while the other ones have less than 1. So if I would have to recommend you to change the diodes, you should change for those the 1N5711, either through hole or SMT, or the BAT62. I tried those two and they work great. I ended up changing for the SMT just for the beauty of the board. Yeah, shame. It might work to use some germanium diodes, like the 1N34, which is going to be comparable in junction capacitance to the starred ones, or the 1N60. The 1N34, I guess, is obsolete, so it's going to be hard to find, but maybe you have a pair of old ones. It's important to match them before putting them on the board, because germanium diodes are kind of hit and miss. So it's pretty useful to measure the forward voltage to make sure they are both on the same level. So that's one of the modifications I made, and that made a whole world of difference, especially because I mostly work on 15, 12, and 10 meters. So I cannot have an ATU that measures the wrong SWR and matches my dipole to whatever. So um, that's what I did. And for those that stayed here, hearing my voice till now, I have a bonus for you. The ATU is famous for doing weird things on high SWR, and that's pretty much because of stray RF inside the box. This PCB is not a really great design. It's a good design. Let me tell you, it's not bad. It's not wrong, but it could be improved. And one of the things I noticed is that sometimes on high SWR environments, it would behave like I have pushed the buttons randomly, and it was kind of annoying, especially on non-resonant antennas, because instead of matching it would bypass. And I said, why? Then after some trials, I figured out that when the box was open, everything worked. So it might be RF inside the box. So I added a few things. I had some toroids on the wires to the buttons. It's just some one wrap on a FT3743. For the display, I added FT5043 because the 37 would not fit, but just one turn. And on each switch, I added a it's small for size, but not for capacitance in RF, 100 nanofarad capacitance. And after I did that, I can match 9 to 1 or 10 to 1 with no weird behavior from the matching unit. So that thing that I keyed up and the tuner went to bypass have ended. I have not this problem anymore. Also, try to route the power cables uh, far from the coils. Although those toroids are containing the field, there's some leakage of RF around the core. It's a small leakage. But if the wire is going exactly on the toroid, you're gonna have RF on the power line, and you do not want that. Also, notice that they only have electrolytic capacitors bypassing the power, which is kind of lame because those guys do not behave as capacitor on RF. So you can also add a few of those 100 nanofarad on the lower side of the board by these electrolytic capacitors. I didn't do that, and I didn't need it. Just by spreading the power lines, the secondary problem I was having was solved. So pretty much try to block some stray RF inside the box, and you're gonna have a very happy ATU 100. And well, on this point, I like to. Oh, there it is. On this point, I'd like to thank the Coffee and Ham Radio folks for pushing me to make this video, and I hope I'm gonna be making some more during the next year. For those listening, it's December 24th, and I wish you all uh, great holidays, whatever religion you have. If you're not religious, have a great resting day, and I'll see you next video. Okay, bye.